Hi, in this video, I will be showing you problem number 53 of chapter 5 section 5, 59 of chapter 5 section 5 and 69 of chapter 5 section 5, all from the practice exam. Let's try now 53. Evaluate the definite integral 0 to 1 7 times cosine of pi t over 2 dt. First, we will write the given integral as I just for convenience. So we can refer that as integral I. I is integral 0 to 1 of 7 times. So we can pull the constant out. So integral 0 to 1, 7 times 7 is taken out. So it is cosine pi half of t dt. Now usually anything in the parenthesis will be taken as u. We will take the substitution as u equal to pi half of t. So du will be pi half, which is a constant, and then derivative of t, that will be dt, differential of t. Now either we can change the limits right now, or we can keep the limits as they are and then get back to the original variable and then plug in the original limits. Either way it's going to work. So it is integral 7 integral cosine of u. This part is u. Then we have to consider this part, which is dt. dt is from here. So in order to isolate dt, you have to multiply both sides by the reciprocal of pi over 2, which is 2 over pi du, which is 2 over pi times pi halves dt. So we notice that these two cancel out. So dt that we have isolated is nothing but 2 over pi du. So it is 2 over pi du in the place of dt. So we get 7. Also 2 over pi is a constant. Pull that out. So integral of cosine of u du. That is 14 over pi. Then sine u. But u, integral of cosine u is sine u. But u is pi half of t. Now we have to evaluate that between the limits 0 and 1. So 14 over pi, plug in the upper limit, which is for t, which is 1. So upper limit, it becomes sine of pi halves, minus lower limit, it becomes sine of 0. So sine pi by 2 is 1, sine 0 is 0. So it is 14 over pi times 1, which is 14 over pi. Let's try number 59. Evaluate the definite integral 1 to 2 e to the exponent 1 over x to the power of 3 divided by x to the power 4 dx. So let's now consider 1 over x cube as our substitution. So let u be equal to 1 over x cube, which in turn can be written as x to the power of negative 3. So du becomes negative 3 x to the power negative 4, or negative 3 times 1 over x to the power of 4 dx. So let's write the given integral as I. I is integral 1 to 2 e to the power 1 over x cube. Let's not write the limits now because we are going to change to the new variable. So the new variable will have different limits, or we will keep the original variable and plug in the original limits, which are 1 and 2. So it is e to the exponent u, because we have assumed 1 over x cube as our u. Then we have 1 over x to the power 4 dx part. So this can be written as 1 over x to the power of 4 dx. So 1 over x to the power of 4 dx occurs here. So we are going to divide this expression du. So du is negative 3 1 over x to the power 4 dx. In order to isolate 1 over x to the power 4 dx, you are going to divide both sides by negative 3. So this part in the integral, which is 1 over x to the power 4 dx, this part can be written as du over negative 3. So which is negative 1/3 integral e to the u du, which is negative 1/3 integral of e to the u is e to the u. Now going back to the original variable, it is 1 over x cube. But this has to be integrated, evaluated between the limits 1 and 2. So it is negative 1/3 e to the exponent 1 over 2 cube, which is 8, plugging in the upper limit, minus e to the exponent 1 over 1 cube, simply e to the 1. So we can write this as negative 1/3 e to the 1/8 or 8th root of e minus e to the 1 or just e. We can also adjust this and write, take the negative sign inside. If we want to avoid the negative sign in front, we can write this as 1/3. We can switch these two terms, so it is e minus 8th root of e inside the parenthesis. The next one is problem number 69. Evaluate the definite integral e to the 49, upper limit is e to the 81, of the function 1 over x times square root of ln x dx. Obviously for this problem too we have to substitute. So u equal to ln x or du equal to 1 over x dx. So the given integral I, which is integral e to the 49 e to the 81 1 over x times square root of ln x dx, can be written as integral 1 over, if you look at the radical expressions, 1 over square root of u, then we have these two, 1 over x dx is 1 over x dx, which is du. For now we can leave the limits alone because the limits are for x. Either we have to change the limits for u, which is ln x. Actually we can try that method for a change here. So I'm going to change the limits in this case, the original limits and the new limits. The variable u is nothing but ln x. So the original limit is e to the 49 lower limit. So it is ln of e to the 49, which is just 49. So for the new variable u, the lower limit will be 49. Then the upper limit is e to the 81 for x. So it is ln of e to the 81, which will become 81. So the given integral, if I keep the integral as integral of u and not changing to the original variable, my limits will become 49 through 81, 1 over square root of u du, which is integral 49 through 81 u to the negative 1/2 du. On integration, it will become u to the negative 1/2 plus 1. So that will be positive 1/2 over 1/2 between the limits 49 and 81. So if you flip the half, it will become 2. Then it is 81 to the power 1/2 minus 49 to the power 1/2. So it will be 2 times, this is square root of 81, which is 9. This is 49 to the 1/2 is square root of 49, which is a 7. So it will be 2 times 2, which is equal to 4. This video helps.